Hello and welcome everyone to this live stream. My name is Amit Chaturvedi and I'm the senior design engineer at Skill Academy. And without further wasting the time, let's start with the today's topic, which is advanced meshing techniques in ANSYS. So let's start with the session today. So this will be the very first screen which you can see. So over here on the left hand side you can see various modules, which is like static structure and various further. So let's just drag and drop like this. And after that you can import, you have to import the geometry. Like always the engineering data will be green text. So engineering data contains your different materials, densities, like ultimate assessment and all. So in the geometry section, just right click, go to import geometry and just browse for the geometry which you want to import. So here you can see the history as well. So I'm just selecting the basic geometry which is square and cylinder for it. So now you can see that the geometry is green tick. Now secondly we have to apply or go to the steps setup setting. So let me just double click. On the bottom left hand side you can see it is showing starting mechanical, which is basically means it will open a second window. This window is overall your workbench where you can import the module, and then you can apply for it. Then in the second window, which is going to open shortly, and it will show the default. So this is the second window. So in this you will be going to do the analysis. So let me just open it. So like this, the model is now imported. You can see that this is a square and a cylinder over here. So what to do next? So since we are focusing mostly on meshing today, so let me just click on mesh, and you can see that element size is default. So let's have a look at what element size basically means. So over here you can see that this is a line. In this line there are infinite points, right? So what we have to do, we have to discrete them. Discrete them as in we have to divide them into subcomponents like this, so that each have a particular length, and this length is what we are calling as element size. Let me just tell you one simple concept. Every point is called as a node. And if you're joining two nodes together like this with a line, then this line over here is going to be referred as an element. Okay. So over here what I can see that, say suppose this overall length is 600 mm. What I have did, I have divided into 6 components, 1, 2, 3, 4, 5 and 6. So basically each element is having 100 mm of length. This is my element size, 100 mm. Let's come to the element size topic. Let me just generate it. I got say, then you can just create like a 10 mm mesh in a Cartesian method. Now you can see that this is the finest mesh which can, the cylinder is also there. So in cylinder you can see that this is the how the finite mesh will look like. Also I'm going to change the method of cylinder as well. So from automatic I'm changing it to tetrahedron generate. So you can see that this is a tetrahedron mesh which is being generated on a cylinder. Now what if I want to change it again? So let's change it. From tetrahedron I'm going with the Cartesian. Generate. So over here the mesh which I'm getting, this is a Cartesian mesh. So basically, both is having a cylinder and the Cartesian mesh right now. Again, you can change it like from Cartesian to tetrahedron and vice versa. So let me just select this time the hex dominant mesh for both of them. So I'm selecting hex dominant and clicking on generate again. It will take a bit of time because you can double click on it to check the progress. So it is showing me right now that meshing completed on one out of two parts, and the second part is practically in the meshing progress right now. So you can see that this is a hex dominant mesh. You can see that from the inside it looks pretty, like not that much good. So you can definitely change that as well. So you can change it from a hex dominant and you can change it to a Cartesian mesh, which is going to be the one of the finest. So let me just generate it. Yeah, so this is my Cartesian mesh. Now, if I want to close the cut section view, so I simply have to click the section plane one, which is check marked right now. So I have unchecked it and now it is closed. So this is simply like how your meshing will look like. So now how to decide on what mesh to be taken. So let's talk on that topic now. So basically, you have these two meshes over here. One is a tetrahedron, and here again the another one is hex dominant. So let's talk about these two meshes. But first, we have to understand the element size again. So over here, if I say that I am taking a 5 mm of element size, and the second option I am going to take a 10 mm of element size, this is going to take a lot of my processing time. Overall simulation right now. So solving the overall simulation, you can just double click on it and it will show the progress bar for it. So yeah, now you can see that this is the deformation which I am getting. But if you look over here, this is the highest deformation which I'm sorry, not here, which is 2.8 into 10 to the power minus 5, which is barely seen, which you can barely see from your naked eyes. What you have to do from the auto scale, just go to true scale. So this is how if you are applying like 1000 Newton of force on the top, and this is how it's going to act in the real world scenario. Instead of acting like this, you can see like it is completely bent right now. But just imagine like 2.8 into 10 to the power minus 5 mm of deformation is barely visible. You can check for the stress point as well. So stress is how much? 0.13 megapascal. You can click on maximum and minimum probes to see for the where the maximum stress is going to generate. So over here, which I'm seeing, it's a point stress right now, which is basically acting on a node. So this is, I'm saying that this is a point stress. So how to eliminate that? Simply what I have to do, I have to change my design. I have to give some fillets over there, like over here, some over here and some over here. Then it can be distributed stress instead of concentrating on a single point. So that's how you can check the maximum and minimum. Over here, you can also click on the probe to see like on every node or on any surface like what is the value of the deformation or maybe the stress which I'm getting. So over here, if I just point like this, so you can see it is showing me the exact same value which is 0.13757, which is the maximum stress if I am going away from it. So like over here. So now it is showing me that the stress is somewhat around 0.08. Now if I am getting a bit far or if I am getting it to the blue region, which is basically the minimum for me. So I am getting stress value as a bit lower than what is usually at the very corner edge. Over here at the cylinder part, you can also check for the stresses. So here what I'm seeing, I'm getting again, point stresses over here just like this at every edge, like that. And obviously at the bottom I'll be getting the lesser one. Total deformation, since I have fixed these two parts, you can cross check as well. So since I've fixed these two parts, so that's why there is a minimum deformation over here, and force is applied on the top, so that's why it is a maximum deformation over here. So that's how you can check them as well. You can check for the meshing as well, like from 5 mm. If you are going with 10 mm, then there might be the accuracy which I'm saying right to you right now. So if you remember, it is the equivalent stress value is how much? 0.13. Okay. Now what I'm going to do, I'm going to change the element size. So let's see what will be the the meshing, and I'm going to change it to automatic for once. I'm just going to change the element size from 10 mm to maybe 50 mm, and I'm going to click on generate. Now for the same force and for the same fixed supports, I'm clicking on solve. Now you can see. Now yeah, thus my accuracy is being like this is not the actual parameter or the actual result which I am looking. So it is now 0.06, which is way lesser than the previous one. It is almost like twice as lesser. Like, so what I'm getting over here is not an accurate result. So you can see that this is my mesh. I know that the length of this geometry is how much. If I click on this, simply this edge, if I select this edge like this, over at the bottom I'm seeing the 1s is selected and the length is 100 mm. But if you see for the deformation over here, so I have given the mesh size at 50 mm. So basically that's why it is dividing into 50 plus 50. So making it a 100 mm length of the edge. So total deformation and equivalent stress. So these are the value. If you want to check, you can check with the previous. You can just seek previously with the video, and you can just see that was the difference. So this is the actual difference which I'm getting. So it is 0.06 in this condition, and if I'm changing to 10 mm and I'm clicking on solve, so first of all 10 mm mesh is generated, then my model is getting solved like this. So it is showing me the overall progress. Now it is almost there. Now you can see the difference. So it is 0.1057 which is coming. Total deformation is this much. On the same parameters I'm saying. So 10 mm is there. Again I'm going to change it to 5 mm. Let me see like what will be the result. So first of all my 5 mm mesh is being generated. You can also see for the processing time which is there. So in 10 mm it is almost like pretty quick. In 50 mm it is more quicker, but in 5 mm if I'm giving the element size, it is taking a lot more time. So this is my actual process time which is being happening, but since my accuracy is increasing, then I can bear that time as well. So over here you can see it is how much? 0.137. On what? On 5 mm of mesh, total deformation this. What if I want to change it to say suppose 2 mm? Let me just solve again. So over here it is starting to mesh. You can see the processing time is getting more since I have reduced the element size. So meshing will take a bit of a time, and same goes with the processing. So this is what I was telling about, like for the element size you can see. So 5 mm is there, processing time will increase and your accuracy also increase. But if you are going with a 10 mm, then your processing time will decrease, and also your accuracy will also be decrease. So you can just simply say that your processing time or your PT is directly proportional to your accuracy. But it is inversely proportional to your element size. The lower the element size, the more is the processing time. The lower the element size, the more will be the processing time. The process, if your processing time is more, the accuracy will also be more. So it's simply just like that. Let me just come back to my analysis and let me see if it is getting solved or not. So right now here you can see that my 2 mm meshing is done on the cylinder, and both the cylinder and the cube. So my 2 mm meshing is done. What I'm again going to do is I'm going to see for the overall progress. So you can see over here that it's taking a bit more of a time because of that reason only, which I've just explained to you on this screen. So this is basically what's happening in the real time. So accuracy, since my element size is less, my accuracy will definitely be improving, but at the same time, my processing time is increasing. So what I have to see, if I want to choose the element size like between 5 mm or 10 mm, I have to see the how much time do I have for encountering any one simulation or one analysis. So you can see that it is still in the progress right now, and it will take a bit of a time because like it's 2 mm mesh first of all. If I want to stop, I can stop that as well from here. So it is showing me that at 40% is there, 40% is completed right now. Let's just wait for it. So now 53% is done, 54th, and just like that it is taking me a bit of a time. But I can say one thing, that at the very end of this result I'll be getting at least a good result for it. So let me just wait a bit more.